So far in this section, we've been dealing with quadric surfaces of a particular type. Now let's think about more general quadric surfaces. What's the most general equations, how we might analyze them? So the most general quadric surface equation that we could write down would be, well, we could have squared terms in x, y, or z. So ax squared plus by squared plus cz squared. We could have mixed quadratic terms of like x times y form and stuff like that. So d times xy. We could also have x times z. And we could also have y times z. And then there's different possible linear terms. G times x plus h times y plus I times z. And then, so these are all of the quadratic terms of just something squared. These are the mixed quadratics, those are the linear. And then finally, we might have a constant, I'll use capital J here, is equal to 0. So this is as general of a equation for a quadric surface as we can write down. And this might feel a bit overwhelming when you look at it at first, that there are terms, there are 10 separate terms here with 10 separate coefficients, a, b, c, d, e, f, g, h, i, j. But as it turns out, in many cases, in most cases, and basically anything that we talk about in this class, we can reduce it down to, we can apply some clever transformations to turn it into something that we've seen before. Like we had ellipsoids, hyperbolic paraboloids, stuff like that. We can turn this into something that we've seen before, though just not centered at the origin. So I'll just write that here. Try to transform into something we've seen before. And maybe not centered at the origin. Okay, so let's take a look here at this example. So x squared plus y squared plus 4z squared minus 2x plus 4y plus 1 is equal to 0. So identify the surface given by the equation here. So again, you might look at this and say, this looks overwhelming. There's 6 terms here, and that's a lot. But one particular type of term, one particular type of term is missing, and that's we're missing the mixed quadratic terms. And so how we're going to attack this is that we're going to try to group the x terms, the y terms, the z terms together. So we have x squared minus 2x plus y squared plus 4y plus 4z squared plus 1 is equal to 0. So now to work with this, we're going to end up wanting to complete squares to turn this into something squared and this into something squared. Well, this will be very easy to turn into something squared here. So to complete the square for x squared minus 2x, we need a plus 1, because then that becomes x minus 1 quantity squared. How did I find that plus 1? I took the coefficient here of the x term, -2, divided that by 1 to get -1, and then squared -1 to get plus 1. Over here, the correct thing to add on would be plus 4, because we do 4 divided by 2 is 2, and 2 squared is 4. And then so this one will become y plus 2 quantity squared plus 4z squared plus 1 is equal to, what did we do here? We added on plus 1 and plus 4 So this is our transform equation, and now it's starting to look a little tighter. Let's make one more change here. I guess two more changes. First off, let's just make the cosmetic change, subtracting 1 from both sides. And let's get it so that the coefficient of the z squared term is 1. So to do that, we're going to divide everything on both the left and the right by 1. And what does this leave us with? X minus 1, quantity squared over 4, plus y plus 2, quantity squared over 4, plus z squared is equal to 1, or x minus 1 squared over 2 squared plus y plus 2 squared over 2 squared plus z squared over 1 squared is equal to 1, or 1 squared. We'll just leave it as 1. And so does this look familiar? We haven't seen this exact thing before, but we should be making some connection to something that we talked about earlier in the section. And that is, well, if we cover up that plus 2 there, and we cover up that minus 1 there, the shadows are kind of getting there. If those things just aren't there, then this looks x squared over 2 squared plus y squared over 2 squared plus z squared over 1 squared is equal to 1. And that's the equation for an ellipsoid that we already talked about. And so by doing x minus 1 quantity squared and y plus 2 quantity squared, this is going to merely shift the center of our ellipsoid. This should feel very similar to like shifting the center of a circle, or shifting the center of a sphere, where, if we get rid of this down here, we get rid of the denominators, x minus 1 squared plus y plus 2 squared plus z squared is equal to 1. This is the equation for a sphere centered at 1, negative 2, 0. So the thing here is that this then, so we want to identify the surface. So what is it? It's an ellipsoid. It is centered at the point 1, negative 2, 0. And its semi-axes have lengths 2, 2, and 1. Where do we come up with 2, 2, and 1? We're just reading off what is being squared in the denominator of these respective terms. And so this is our ellipsoid. I will just, instead of drawing this, I borrow this example from the book. Let's just take a look here. So you can see we are centered at x is 1, y is 2, and z is 0. So there's the center. And going in the x direction, we go to the radius, quote unquote, the radius is 2. Going in the y direction, the radius is 2. Going in the z direction, the radius is 1. So that is what we do if we are in one of these more general cases. So this was something where we accomplished it we figured out what was going on by translating, so this was merely an ellipsoid, but translated to not be at the origin. Sometimes you might have to rotate or reflect or something like that. There's lots and lots of possibilities. We could go on and on and on. But the point here is try to do some manipulation to make it look like something you've seen before.